Hey kids, today we're going to do the lesson with matrices and lots of calculator use. So you need your calculator to go through this video, and you also need your calculator to do this homework here. So solve the second order. Second order just means I have two equations. I have a system with two equations. So remember, a system is either independent, inconsistent, or dependent. So using matrices to solve this, remember I make a coefficient matrix with the first column being the coefficients of the x variables and the second column being the coefficients of the y. I only have two variables that are used in both equations, x and y. And my answer matrix is a 2 by 1 that has a negative 5 and 8. So I set up my Savart equation. I'm going to leave this spot here, because I'm trying to isolate the xy variable, which means I need to get rid of the 1, 3, 2, negative 3. And to do that, I use the inverse. Right, so I'm going to multiply this matrix on the left by its inverse, which will give me the identity matrix. But that's not legal unless I multiply this side of the equation also on the left side of this matrix. To calculate C inverse, to find C inverse, I need the determinant of the coefficient matrix, which is negative 3 minus 6, or negative 9. Times the adjoint, which is switch them on the main diagonal and negate them on the minor diagonal. So I'm going to put the inverse here and not really multiply, because I already know that this product will give me the identity. But over here, I will not get the identity. I just have to follow the rules of multiplication here. So I have to do the dot product with the first row and the first column. Oops, I wrote the coefficient matrix and not the adjoint, didn't I? So negative 3 times negative 5 is 15. Negative 3 times 8 is negative 24. 15 minus 24 is 9. But it was positive 15, negative 24, so this is negative 9. Then I have positive 10 and 8, so that's positive 18. So of course that was times xy here, and the identity matrix times xy is just xy is equal to positive 1 and negative 2. Now remember, this was not just solving a matrix equation. This was way back up here to matrix world, saying that the solution to this independent consistent system, the solution was the point 1, negative 2, which means that 1 plus 3 times 2 should equal negative 5. Whoops, I'm sorry, negative 2. So sure enough, that is true. And also 2 times 1, which is 2, minus 3 times negative 2 should be 8. And all of those check out. So on your test, you will be expected to do this. Solve a second order linear system using inverse matrices, and you will not have a calculator. But now let's talk about when we do have a calculator. But before we do that, I realized that in using con videos to teach you the first operations here, you know, the adding, subtracting, scalar multiplication, and multiplication, I skipped one of my favorite parts. So teaching this myself, the matrix product of A times B, I used these two matrices, a 3x2 and a 2x3, and taught the kids that the rules for multiplication was that the columns of the first have to match the rows of the second. And then I taught them how to do the dot product. Oh no, first I taught them that the resultant matrix then was the rows of the first with the columns of the second. So I have the columns of the first match the rows of the second, therefore yes, I can multiply, check. Further, my resultant matrix will be the rows of the first and the columns of the second. And then I taught them how to multiply is each element of each row of the first matrix multiplied times each element of each column of the second matrix. And then you add those together, which we've called the dot product. Right? Dot product. So there's the first row, 2 and 3, and the first column, 1 and 1. So you multiply 2 times 1 and 3 times 1. Then you multiply 2 times 1 and 3 times 0. Then 2 times 1 and 3 times 2. You repeat the process with the second row. Go through the first column, second column, third column. Then you go to the third row. And you repeat the process. First column, second column, third column. And that's what my working matrix, I call this my working matrix. It is worth having a working matrix if you're going to do a lot of this math by hand, so that in case you make a silly mistake in here, I can see it and not ding you all points when you have a 1 here instead of a 2. So after teaching them, I would then give them a little song to try to remember this by. So and the song goes along with an old song from, I don't know where. But Oh Clementine, right? You went, no, stop! There you go. And it's on video. Holy cow. Alright, time to get out that calculator. Delaney, I just sang to my class on YouTube. So, here's your calculator. And the directions are to enter the follow. So, of course, you don't know how to enter anything into your calculator yet, but if you look right above your X button, it says matrix. I guess first I better turn mine on. So go to the matrix. Now this screen is where you're going to call up the matrices, the matrix names to your home screen. So I really don't do anything here. If you arrow over one, you'll see some things like debt. I wonder what that means. And that little t. I wonder what that means. Identity and augment. All of these things, there's lots of things to do with matrices here. We are really only going to deal with 1 and 2. But arrowing over all the way to edit is where you actually enter matrices. So I'm going to go ahead and hit 1. And if your memory has been cleared, this is just going to be default back to a 1 by 1. So first you have to tell it what size matrix I want. So matrix A is a 3 by 3. And then the entries are 3, whoops, -2, -2, whoops. So there is the first matrix. So I have to back out of this and do second matrix, arrow, arrow, edit, and hit 2 to enter matrix B. Matrix B is a 3 by 2. There's matrix B. Now, back out of it, back over to edit, matrix 3, which is called matrix C, which is also a 3 by 2. And then I'm going to quit back to my home screen. Now, we're going to use our calculator to do all of these. So on the calculator portion of the test, if I'm asking you for any computations like this, you do not have to show me any work. I literally just need you to do this with your calculator. So let's see. Let's do this first thing. How do I do A times B? So this is where I use that first screen, or that first menu, and this is where I call up names. So matrix A times matrix B. And remember, that's a 3 by 3 times a, right? 3 by 3 times a 3 by 2. So that is going to be able to be multiplied, and none of that row by column, line by line, or anything like that. No dot products, no whatever. Hit the enter button. And there is your answer. Sweet, right? Now, just to show that matrix multiplication is not commutative, right? What if I do second enter, but instead of doing, whoops, instead of doing this matrix B, I'll do matrix B times matrix A. Dim mismatch. So doing a dim mismatch, right? Dim, what do you think dim stands for? Dimensions, that's right. So this is how the calculator is telling me, I can't multiply, silly. Now, can I multiply C times A either? So, look, error. Can't do that. Am I going to be able to multiply C times A? A 3 by 3 times a 3 by 2. Right? So CA. So matrix C times matrix A. C times A is a 3 by 2 times a 3 by 3. Not going to work, right? If you ask it to go to, it could send you back to the screen and says, you see after what happened after matrix C? I can't do what you want. So what about this next thing? What is this asking us for? Right, this is asking us for the determinant of A. So remember I showed you that before. Let's go to second matrix, arrow over just to math, and ask for the determinant of matrix A. Now matrix A is a 3 by 3. You know how to find that by hand, but if you have a calculator in your hand, I'm not expecting you to do that work. There's the determinant, -95. Right? No work, no augmented matrix, no 3 diagonals and 3 minor diagonals. None of that. Now I also want the determinant of B. So I'm going to do second enter so that it pulls up my last entry and edit a second matrix B. And, hey! I got another error message. How come? Invalid dim. Again, what do you think dim stands for? Yes, dimensions. So what do you mean? What's the matter with the dimensions? Let me find a determinant of a square matrix, right? So matrix B is not square. So now what about over here? A times B minus 3 times C. I can just type this right on my home screen. Matrix A times matrix B minus 3 times matrix C. Now this is, right, a 3 by 3 times a 3 by 2, which means I'm going to get a 3 by 2, minus, now I can't subtract matrices unless they're the same dimensions. So the product of AB is a 3 by 2. What is C? Oh, C is a 3 by 2. Good. So if C is a 3 by 2, what is the multiplying by a scalar? Doesn't change that, so I should get an answer. Very nice. Now, how about C inverse? Matrix C. You actually have an inverse button on your calculator. Do you know where it is? You might think of it as a reciprocal button, but that's not a reciprocal button. It's an inverse button. C to the -1. Right? It just so happens for numbers that the reciprocal and the multiplicative inverse are the same for real numbers. But that is an inverse button. So what does C inverse look like? Oh, crap! Invalid dimensions. C isn't square. So of course to find the multiplicative inverse you need the determinant, but I can't find a determinant unless it's a square matrix. So I can't find the inverse of C because it's not a square matrix. But how about A? A is a 3 by 3. So it is a square matrix, so I should be able to take my entry there. What is that? Now remember, we found the determinant of A way back here in the right before. Remember that? We found the determinant of A. So, you see this arrow over here? This arrow means that you should be able to go over and see, because I know my determinant is a 3 by 3. right? It's just a bunch of irrational numbers. Well, check this out. If you say math, turn decimals into fractions, take the answer, turn everything into fractions, and look at what happens. Gee, look at all those 95s in the denominators. Remember what the determinant of A was? Yep. How do you suppose there are some denominators that were 19? Why don't you think about that one, huh? Alright, how about the transpose of B? Second matrix B. And then I want its, now I don't really need a calculator to do a transpose. It really isn't that hard. But there is the transpose. Right? The first column of B is now the first row, or vice versa. The first row of B is the first column of B transpose. What about B transpose cubed? Now why is that? I typed in everything all right. Because B transpose is what size? A 2 by 3, right? And you can't multiply a 2 by 3 times a 2 by 3. So I certainly can't multiply it 3 times each other, can I? Now I could do A transpose cubed, right? And look how fast that happens. Alright, so that was basic operations, adding, subtracting, determinants, transpose, inverses. Now, how about we use the calculator and our knowledge of inverse matrices to solve higher order linear systems. So instead of a 2 by 2, what if we had a 3 by 3 or a 4 by 4 or a 20 by 20? So there's my system. Notice it is a 3 by 3 system, 3 equations, 3 unknowns. To start this, I start just like I did with my 2 by 2, right? I create 3 matrices. My coefficient matrix is a column with all my x coefficients, a column with all my y coefficients, and a column with all my z coefficients. Next, I make a variable matrix. Only this time my variable matrix doesn't have just x and y in it. What does it have? X, y, and z. And your answer matrix? 3, 8, and negative 22. Just like I did with 2 by 2 matrices, I'm going to create a matrix equation, SAVA, and find C inverse. So I'm going to write and I'm going to leave that same space. case. What was it? 1, 2, 3, and -2, 1, and -1, and 3, 5, -3. And my answers were 3, 8, -22. And what I'm going to do, just like I did before, was I'm going to multiply the matrix I'm trying to get rid of on the left side by C inverse, which means on the other side of equation I have to find the matrix and multiply on the left side. To find C inverse, though, I have my calculator. This is a 3 by 3 matrix. I've taught you how to find the determinant, but I haven't taught you how to find the adjoint, and I'm not gonna. You can look it up if you really, really want, and it's just, could not be any more fun. But I'm not building time in for you to do that on our unit test. This is going to be on the calculator portion. I expect you to tell me what C inverse is. And I'm going to expect you to tell me what C inverse is, and I expect you to write it here. Oh, dagger. And here. I know when I multiply all of this together, I am just going to get x, y, and z. And then I'm not going to multiply these two. I'm going to let the calculator multiply these two, and it is a 3 by 3 times a 3 by 1, so I'm going to get a 3 by 1 matrix when I'm done. Now I don't want you to copy over the elements of the inverse twice. So you can literally tell me you're doing, instead of putting this up here, you can literally write C inverse here. However, I do need to see the inverse at least once. So I'm going to put multiply in quotes, because you're not actually going to multiply. You're going to use the calculator. So I need to edit matrix C, and you can do whatever you want, but I'm going to do C as a 3 by 3. You can just put it in matrix A if you want. I like to be cute. Before I do anything, I always check to see if there's a data entry error. 1, -2, 3, 2, 1, 5, 3, -1. Oh, see there? 2, 1, -3. Then I'm going to go edit matrix A for the answer matrix. Oops. What the heck? Gosh darn it. Matrix A, my answer matrix, is a 3 by 1, and it has 3, 8, -22. I'm having some keystroke problems, aren't I? Now notice, what I actually need to do is multiply C inverse times the answer matrix. Remember, I don't actually have to multiply these two matrices. I'm going to get the identity matrix. The identity matrix times XYZ is XYZ. Now I have to take C inverse and multiply it times the answer matrix. But I told you that I want you to write down what C inverse is, at least once. So get C inverse, oops, it's getting late. I don't want to write all those down, so I'm going to turn it into actions and copy all of those down. So somewhere on your paper, I don't care whether you write it here, write it both places, or write it off to the side, but somewhere I need you to write down the entries of C inverse. After you've done that, on your home screen, just tell me what C inverse times the answer matrix is. So write all those 32/5, 1/5, and -1 in there. And that is how you solve the system of higher order. So what do you suppose one of your homework problems I gave you is a 4x4. So do you suppose you could do the same thing? I believe you can. Just looking to see, make sure that it is, I gave you one. Also, let me double check my math here. I'm not too sure that this problem was supposed to have those fractions as answers. My 3x1. Ah! You guys probably saw that all along, didn't you? So annoying. -22. So that's not going to change C inverse. C inverse was alright. There, much better. -4, 1, and 3. So that is my answer to the matrix equation. But don't forget, this is not, I didn't start with the matrix equation, right? Remember, I started with a system. Right? I had equation 1, equation 2, equation 3. Its answer, its solution, is an ordered triple. Right? So don't forget to take your matrix answer. When you're just doing a matrix equation, you leave your answer like this. But this didn't start out as a matrix. I brought matrices into the situation. So I'm going to finish my answer with an ordered triplet. Okay? Alrighty. So, have fun with your calculator and doing this work. Don't get too frustrated with your calculator. And it just takes practice. Don't forget all these problems, 3 through 13 odd, and I did give you, I think 13 is the one that is a 4x4 to solve. Alright. Have a great evening.